Hello all. Now we are going to discuss about the concept of clustering and various clustering techniques in detail in this video session. So this is the outline of what we are going to discuss. We'll be starting with introduction to clustering. Next we'll be understanding the difference between prediction and clustering. The next it will be continued with various document clustering types, and then finally we'll be ending up with similarity computation. So what is clustering? There are two different learning mechanisms in data mining which we have discussed in previous video session. One is called as supervised, another one is called as unsupervised. So in supervised, it is also called as prediction or classification. So here we'll be already having a trained label data set which is labeled manually, that is the trained data set will be already classified and given to your hand. So your machine has to learn some features from the trained data set which is already classified, and based on the learning, now when a new data set has been given to the machine, it understands the particular features of the data set, and it is going to identify in which particular class it is or in which particular label it is. So this particular label data set will be your spreadsheet, where the last column of the spreadsheet will be the label or the class for the corresponding category. So here we already have a training data set. Your machine learns based on the training, hence it is called as supervised learning. The other one is called as clustering, which is called as unsupervised. Here there will be no training or predefined label which has been given to you. The dataset will be raw, and based on the dataset you have to understand the particular features and you have to cluster without any training. That's why it is called as unsupervised, and hence the name is says as unsupervised. The performance of this will be automatically reduced because the prediction, we will be already having a training dataset, so your model is very well trained enough. But here there is no model, there is no predefined data set, there is no training given to the system, so automatically your performance will be reduced. So the drawback will be the same number of labels may not be result as you are expecting for, and the purity of the cluster will not be the same as like you are preferring. So if the purity is low, we have to go to the algorithm, change some attributes, and again measure for the purity at most for your target level. So this picture says what is the difference between prediction and clustering. So the first part of the picture says about prediction. So as I've already mentioned, here we will be having a trained data set where each and every row is a document. So the last particular column which is present over here is a label. The rest of the columns are the features of each and every document. For example, if you take document 1, the first feature is 1 is present for this document, the second feature is not present, like which it goes on, and it has been classified to second particular category which comes under sports. Similarly, the second document, it doesn't have 3 features and it has the last 2 features, and finally it has been classified with first category which comes under finance, like which this training data set will be present with labels, and based on this your machine will be learning, and finally when a new document which is not listed above has been given with all these features marked, your machine will be predicting which particular label it belongs to. When come to the next part, which is called as clustering, there is no labels present over here. For example, document 1, document 5, document level, everything are grouped together and given to you. So your mission has to understand what is the similarity between the two documents. For example, document 3 and document 6. If they both are very close with each other, similarity level for these two documents are very close with each other, they will be clustered as in a single cluster. But for example, if document 3 and document 1, the similarity between these two documents are not matching or not under a threshold, not within a threshold value, the particular documents are classified into two different clusters, like cluster 2 and cluster 1. So after clustering all these based on the similarity levels, finally we have to label each and every cluster, which in classification it is already given, but in clustering, which is not given, the machine has to automatically label it based on some mechanisms. The next concept is document clustering. So in document clustering, it is again we are going to group similar items together where the items is nothing but each and every document. So a cluster is called as similar documents where the similarity is measured based on something called as keywords. And the target here we have to set is that we have to maximize the intra-cluster similarity and minimize the inter-cluster similarity. For example, the similarity between the particular documents within a cluster should be maximum and between two clusters should be minimum, so that the gap between two clusters should be maximum. And the labels are not known, which I have already said. The measure of the similarity is used to group the documents. The similarity is a key concept over here. So how to measure similarity we can discuss later in the slides. After clustering, as I've already mentioned, we have to label each and every groups based on the keywords which is present in the documents. So this document clustering is mainly used to find the structure, or it is used to organize the data, and it is used to reduce the manual labeling burden. So in classification we have already mentioned, if you have 100 training data sets, for all the 100 training data set the label has to be predetermined. It has to be either meant manually or some automatic means, but we are in need of label before we start our work, but that is not happening in clustering. So the particular manual labeling burden has been reduced in clustering. And some of the examples where clustering is used is that call center complaints. So when complaints are coming from the call center, it may not be predetermined which particular class it is coming. So we have to cluster based on the similarity between the complaints. And the common search engines are using clustering rather than classification because the labeling consumes more time if you go for classification. So this is how the similarity computation is happening over here. So if you take a set of documents which is pre-clustered, and when we give a new document which is yet to be clustered, the similarity computation computes what is the similarity between the set of documents which is pre-clustered and the new document. Based on the similarity score between document 2 and this set of documents, the particular document 2 will be classified which is having the maximum similarity score. So for this computing the similarity score, we can either use cosine similarity or some other novel similarity mechanisms. So here that is an example where we are having three documents. The three documents may be present in whichever cluster may be. So for three documents we are having three different vector values like which. Now this is a document which is yet to be clustered. So when we compute the similarity, the basic similarity computation mechanism is used here, where each and every vector value, feature vector, is multiplied with the new document's feature vector. So like which it has been multiplied and summed together to form a value. So based on this particular value, it clearly shows that the last document will be having the highest similarity value, which is nothing but 0.5. So the new document will be classified under third document's cluster. So for further reference, you may also refer this particular books or also web references. Thank you.